hopefully you can read it. It says, suppose you stand 10 feet away from the base of the Washington Monument and shine a flashlight at it. Let X be the number of radians the light beam makes with the horizontal line. Let Y be the vertical distance from the flashlight to the spot of light on the wall. So, draw a quick picture. We've got the Washington Monument, with a big crayon, standing on the ground. Here we are with our flashlight. And we are 10 feet away. And then we're going to take that flashlight, we're going to rotate it up the wall. And Y is going to be the distance from the light to the ground. And X is going to be the angle of rotation as we move it up. Okay, what they want us to do on the first part is to show that Y is actually equal to 10 times the tangent of X. Well, this is just a trig function. We're going to stand at our angle. And if you look at these three parts, this is the opposite. This is the adjacent. If you remember SOHCAHTOA, we've got opposite and adjacent, that's tangent. So what we can do is say the tangent of X, the tangent of the angle, is equal to these two sides of the ratio, Y over 10. And if I solve this for Y, I put a 1 under here and do cross product, Y times 1 is equal to 10 times the tangent of X, the other cross product. Okay, so that was part A, just show where this equation came from. And then you are going to do some calculus stuff for rates and business like that. Okay, and my last example is doing one of your antiderivative problems in number 43, I believe it is. I'll do C with you. It says if the derivative of some function is secant squared 5x, can you figure out what the function was to start with that has that derivative? Well, you first have to ask yourself, what trig function has secant squared as its derivative? If you look, secant squared is the derivative of tangent. So your original function had to have tangent so that when you do the derivative, you get the secant squared. So, just like before, we're going to leave a little space for any coefficient we might need. But I know the original function had to have the tangent of this angle. So to figure out what this has to be, we'll just start with this derivative. If I left it Y equals just tangent of 5x, the derivative would be derivative of tangent is secant squared 5x times by the derivative of the angle of the 5. So it would be 5 secant squared 5x. Well, I don't want a 5 as a coefficient. I want a 1 to end up being the coefficient. So I need something that will cancel out the 5 in front here, and that would be a 1/5. And now if you check the derivative, you would have the 1/5 multiplier here. Tangent derivative is secant squared times 5x times 5, and the 5 and the 1/5 would cancel out, and you'd be left with a 1 in its place. So we needed a 1/5, and don't forget, plus 3. Okay, your assignment on this section is going to be page 143, 17 through 36, and pick up 41 and 43. And we already did part A on this one, and we did part C on this one.